morning and welcome to the webinar. This is Getting Started with SQL Diagnostic Manager Pro. My name is Justin Wilkes. I'm going to be your host. All right, let's get going. So again, my name is Justin Wilkes. I've been with IDERA for about 14 and a half years in different roles and capacities. Today we're going to be doing a 1-hour webinar or discussion on SQL Diagnostic Manager Pro. This is going to be recorded, so anyone who registered for the event will get a link to the recording so they can go over it. We have a questions piece in GoToWebinar. If you have any questions or areas that you definitely want me to cover, please put them into the questions piece and I'll make sure to address them as they come up. That being said, let's sort of get started and talk about what do you do. Oh, and actually, before I even go over that, we're not going to go over any slides today unless y'all want to. The concept of this webinar is maybe you're trialing the product and you're trying to figure out what areas to go to and what you can see and what you can do in the tool, or maybe you're new to a company and the company already has Diagnostic Manager and you'd like to learn it better so that you can be more proactive in your SQL environment. These are all, those are the areas that we're going to try to cover. We're going to try to help take care of both of those different audiences. Okay, so that being said, I'm not going to cover the architecture. The assumption is that the tool is already installed, but if anyone wants me to cover the architecture, and then just put into the questions piece, and I'll be more than happy to discuss the ins and outs of how the product works. But okay, so let's imagine we just got Diagnostic Manager installed. Here you can see my installation of Diagnostic Manager, and hopefully everyone can see. Yes, everyone can. And you can see that I'm monitoring 10 different SQL instances. Typically, when you get started with Diagnostic Manager, one of the things that people have a hard time working with or a hard time dealing with is that all the SQL instances that you add all have red X's on them. And so it's hard to distinguish if there's any real problem or what the problem is because everything's red. So let's sort of talk about how we can clear those red X's up and adjust before we talk about the more fun sides of the tool where we can, look at sessions and look at queries, look at query weights and that kind of thing. So when you install the product, the first thing that's going to happen is a wizard's going to pop up that asks you to add SQL instances. When you're adding an instance, and I'm just sort of going through that wizard right now, at some point, I'm going to hit cancel here. At some point, we're going to apply what's called a template. The template is a starting point. And I mean, when I say starting point, I mean that it's a set of metrics we think you want to monitor with thresholds preset on those metrics. Now, what we've found is there's no one-size-fits-all solution for anyone. Everyone has different environments, different SQL servers, different memory requirements. There's a whole bunch of variations in everyone's SQL environment. So the templates, like I said, are a starting point. If you would like to look at the templates, they're available under this little wrench. If you open the wrench, you can see alert configuration templates. We ship this product with a few different templates. Almost everyone starts with the default template as a starting point. It's a good middle ground, right? But we do have critical only. This is for your QA boxes, and performance template. That's for your super important SQL instance, like really super important one that you really want to push as much resources as you can to. And then we also have databases as a service in Amazon and Azure, and also a managed instance template in Azure. So just as a side note, these templates are available, but like I said, starting point. So as you add your SQL instances, you're going to add a template. The next thing that's going to happen is that if you look at a SQL instance, and I'm going to focus really on this Columbia instance. This is going to be the one that I'm going to be showing the most during this demonstration. If you are looking at the thumbnails and you double click on that thumbnail, it's going to bring you into that server's main dashboard. So we're in the server section, and then all these different areas at the top are areas that you can explore within any given SQL instance. But I'm going to look at this Columbia server, and if I right-click on the server and go to Configure Alerts, this is going to show you the metrics that are set, and it's going to show you those metrics set by the template, right? The template turned on different metrics and set thresholds in those metrics. And so, like I said, that's that starting point that we're talking about. So let's look at the, for example, OS memory usage. A lot of times this metric is set incorrectly. By default, I think it's gonna set memory consumption at 85 and 90. So 85 being a warning condition, 90 being a critical. You can see I've changed mine. But like I said, the default template is just setting everything up. The next thing you want to do is make sure that you're baselining your SQL instances correctly. So baselining is automatic. As soon as you add SQL instances, we'll start to try to figure out what's normal in your environment for any given metric, right? That's what we're gonna do. The baseline configuration is here or in the properties. There's multiple ways to get to it, but basically we're going to develop or try to figure out what's normal in your environment, and we're going to either do that one of two ways. We can either do it dynamic or custom, and custom is really sort of, I would change that word with static. But dynamic is a rolling baseline. This is a baseline developed over the last 7 days, and what we're doing is we're averaging any given metric and then adding and subtracting a standard deviation to give yourself a reference range. And in the background, you can sort of see that reference range. So the baseline found the average for me is right here in the middle, and we added one standard deviation north and one standard deviation south to give you the reference range. Now, the reason this is so large is because I reboot this server all the time. In the SQL world, like most of the DBAs are on this call, you're not rebooting your SQL instances that often. So the information that will show up will be, the reference range will be a lot tighter as opposed to this one. This is showing this metric is very fluid, or it's fluctuating a lot because I'm rebooting my SQL instances a lot. So a few things to note. When you're generating a baseline, you want to specify the days of the week and the hours of the day where that SQL server is doing its most work, right? So by default, we look at this Monday through Friday. We look at it 8 to 5 p.m. By default. You can also, by the way, add in multiple periods of time. So let's imagine I've added in 8 to 5. Let's imagine that's the work period for that SQL instance where it does its primary work. Well, what about if it has that SQL instance is used by a different team on the weekend, or maybe a different team at night, or you have an ETL process? Well, note that if you hit this manage baseline section, you can specify those other periods of time. And that's actually a really cool thing to do, because one of the things that I'll show you in a second is that our metrics can be either static or dynamic, and I'm going to go over that in a little bit. But let's imagine we've added the primary period of time here, and then we've gone in here and we've added our ETL process that happens in the middle of the night, and we've added our weekend warriors that are doing the work on the weekend. So we've added in 3 different periods of time for the server to baseline, or for Diagnostic Manager to baseline the server. One of the things that's really nice, and if you look over here, you'll notice that some of these metrics sort of seem to repeat themselves. For example, OS memory usage by %, and then underneath it we have OS memory usage underscore baseline. And they're almost the same thing, except for what the difference is that if you look at OS memory usage by %, you'll see that we have a hard-coded number, 95 and 99. Those are hard-coded numbers for warning or critical conditions, right? They're not going to change, right? On the other hand, if I go over here to OS memory usage underscore baseline, you'll see 50, 100, and 120. And it seems a little bit odd when you first look at this. What this is really telling you is that this metric is going to alert you not based on a hard-coded number like 95 or 99% or anything like that, but it's going to actually alert you when you get or deviate out of a certain percentage or deviate out of the baseline percentage, right? So Let's imagine we're looking at how many people are connected to this SQL instance, client computers count right here. I have a hard-coded number of 5 and 10, right? that's a very low number, but let's imagine that's who uses the SQL instance at this time. If I was to change over to client computer count baseline, this would say 50, 100, 120. Well, what's it saying? It's saying that based on the periods of time, based on the baseline configuration, I'm going to alert you when you get out of what's normal for that period of time. So let's imagine during the day you have 100 people using the SQL instance, and at night you have 10 people using the SQL instance. Well, let's when you got the average would be 100, or the baseline would find the period the average for that period of time. So it would say, during the day at 100 that's normal, 110 that's the top of the baseline, and 90 is the bottom. So if you got to 110, that'd be 100% of the baseline, so that'd be a warning condition. But then if you went to 100 and we'll say 120, just for ease of math, it's probably 130. But if you got to 130 people, that'd be a critical condition. Now that's during the day. Now at night, if you've got your baseline configuration set correctly, it's going to change. So once this metric would alert you if you did this, if you got to 110 during the day for people connected, but it would also alert you if you got to 11 at night, or go into a critical condition if you got to 13 at night, if you'd specified that period of time in the baseline configuration. So the thing that's nice about this is that you can, if you have different workloads or different groups that are using a SQL instance, you could adjust the metrics so that you're not getting false positives, and you're not getting alerts that are not correct. The most important thing that we want to do is get your SQL instance into a scenario where you've got more green check marks. So we want to clear away some of the conditions that are extraneous or really just don't make a difference. And I'll give you some examples. One of them might be going in here, configure alerts again. One of them might be CLR being enabled. We have that as a metric. So your servers might be red because CLR is enabled. Well, if you have CLR enabled and that's the alert that's causing your SQL instance to be in a red condition, just assess the scenario and say, okay, do I need CLR? Oh, maybe I do because this application requires it. Well, if I need it, then this is a false positive. And if it's a false positive, you want to get rid of the checkbox over here, and so your server can go into green condition. Another adjustment that I think everyone really needs to make is memory. Usually we tell our SQL servers to take all the memory that the box can offer. So I would go in here and for OS memory usage, either use the baseline edition over here, or change the hard-coded numbers in the top metric to a higher level than what's seen in the baseline statistics. Another thing you can do to help sort of clear out the metrics and make sure that the metrics are correct for your SQL environment is you can make exceptions. So, I've got 10 SQL instances, but let's imagine for this SQL instance, I have one hard drive. I have one hard drive that is not database. Let's see. Sorry, I just turned into this dark mode, and it's actually pretty hard to view. Let's imagine I have one hard drive that is here it is. Sorry, one hard drive that's an archive box or an archive drive, and it's 99% full. Right now, typically you're going to want to give yourself some leeway. So for default, your hard drives, you might want to put in 90 as a warning condition, 95 as a critical condition. But this archive drive, it's a static drive. We've filled it up. We're not changing the amount of data that's in that drive. We don't need to change the amount of data that's in that drive. Let's make an exception. Well, With all the metrics in Diagnostic Manager, you can do that. So for example, I could add down to a specific drive, specific metrics. So let's imagine this is my archive drive. I could add Z. I can get rid of warning. I could put critical at 99. And now I have an exception that I've added for that one archive drive. Now the whole idea behind this is that we want to smooth out the metrics so you're not getting false positive. One of the things that when I was in IT, one of the things that was really frustrating to me was getting so many email notifications on any given night that I couldn't respond. Like I had this product called PRTG, and PRTG would send me 30 emails a night. Well, if you're getting 30 emails a night, pretty quickly you're going to stop paying attention to that monitoring tool. And once you stop paying attention to a monitoring tool, then it's not necessarily doing any work for you, right? It's not helping you at all if you're not paying attention to that monitoring tool. So the most important thing in my mind is to clarify the metrics and get rid of the false positives. Now I'm going to also talk about this. Like let's imagine you just got started, all your SQL instances are red. Where would I go to see all the different metrics that are causing the SQL instance to be in a red condition? Well, the answer is I would go to the alerts view. The alerts view will show you all the different metrics by server, and what you can do is actually group this. And let's look at this Columbia server, for example. I can look at all these different metrics, and I would go in and I'd say, okay, so let's get rid of this SQL agent job metric, right? I want to get rid of this metric. Well, how do I do that? Here's a really easy sort of trick. You just right-click, and you say configure alerts. Oh, hold on. Oh, hold on. And it's going to take you to the server where that alert was in a warning or critical condition, and it'll take you to the exact metric. Like that's the metric that'll be highlighted. So if you're in the alerts area, this is where you can clear up all sorts of different metrics and and sort of make sure that the servers are in a green condition. The more time you spend doing that, the more effective the monitoring tool is going to be. So that's just something to consider. The more effective it is going to be if you clear out the false positives. Now, another thing to mention is that when we talk about monitoring, there's two sides of it. There's monitoring and having a history on the SQL instances that are in your environment. Obviously, that's great because you can go back and use our history browser and view older data and know scenarios that are in a warning or critical condition. But the other side of it is, do you want to get alerted on all of those things? And the thing that's nice about this tool is that you can literally pick and choose who gets alerted, what you get alerted on. You can monitor for everything and still at the same time not get alerted on everything, right? So what you get email notifications on is configured under this tools or wrench icon. If you open it up and you can go to alert configuration, alert actions and responses, this is the alert area. Now, by default, we don't have any alert rules that are going to send you any information. In fact, by default, I think we have this newsfeed alert and we have this SQL Diagnostic Manager service status alert, and that's the only two alerts that are given by default. So it's sort of incumbent on you to configure your email notifications in a way that makes sense for your environment. Now, a few things to mention. Email notifications are just sort of the tip of the sword. You do have the ability to run all sorts of different action providers. So you could run a script, a T-SQL script against the instance when a certain problem occurred. You could run a job. Maybe if a server hadn't been backed up, you might want to run a backup against that instance. You can run an executable. You can run any PowerShell command, and that's actually one of the more effective things to do is run a PowerShell command against an instance. You have a lot of different options when you think about what's available within PowerShell. I'm going to skip the news feed because no one ever uses it. You can also, of course, fire off a trap. So if you have another monitoring console that's monitoring all the rest of your servers and you want to push information to it, then of course you can fire off a trap to that SMTP console or SNMP console. And as a side note, we also do have MIBs. So if you want to register our MIBs with that SNMP console, you can absolutely do that. We also push information to the event log. And there's other components within Diagnostic Manager. I'm going to discuss all three of these components during this demo. But all these three different components can be turned on or turned off as needed as well. And of course, your last option is that you can fire off an email to a distribution list or a set of different email addresses. It's up to you. So again, you can have as many alert rules as you'd like. So what I usually do is I start off by setting up my email notifications, and I like to set up my email notifications by day of the week and hour of the day. Excuse me. So why I bring that up is, during work hours, I'm a lot more willing to get email notifications. Right. So this is a 3-step rule. You can go in and say, this is the criteria for what I'd like to look at. This is the actions that I like to take, and down here you fine tune the rule. Right. So for work hours, you can see, and it actually is a little bit hard to see, but you can see I'm talking about 7 a.m. to, wow, it's really hard to see, 6 p.m. Monday through Friday. These are the metrics that I'd like to get alerted on. And again, during work hours, I'm a lot more willing to get an email notification. So if the CPU is at 90% during the work, I want to know immediately, right? So I can look at it and see what's going on. On the other hand, on the weekend, do I necessarily care about the CPU being at 90%? And the answer for me, and everyone has a different approach to this, but the answer for me is that on the weekend, if everything's online and still running, then I probably don't want to get an email notification where I might have to leave dinner with my family or come out of a movie theater to look at my phone to try to figure out, or leave any event that you're having on the weekend with your leisure time for the CPU being at 90%. One of the things that's nice about having a monitoring tool like this is that you can go back in time. We can go back and look at that event after the fact, and that's fine, right? So on the weekends, if I get an email notification, I want email notifications on just some specific things. Is our database is offline? Is the SQL server offline? Am I running out of disk space? Is everything, is everything running? But it's basically just status alerts that I care about on the weekend. Now, again, everyone has different approaches. You can customize your alerting in whatever way makes the most sense for you. Looking at this, though, email notifications, like I said, that's a great start. But we also have the ability to react to things, and I'll give you an example. Here is my killing block sessions response, and what I've done with it is I've said, hold on a second. Sorry, my kid just walked into my office. Okay, so if a session's blocked and I want to automate the response that actually fixes that scenario, I can do that. So here, I've gone in and I've said, if there's I've created this alert and it's for killing blocked sessions. I've gone in and said if a server belongs to QA, so this is this group QA. So out of my 10 servers, 2 of them are in this group QA. I've said if in QA, if a server has blocking and it's a critical condition, then I want to run this T-SQL script to kill the lead blocker. So I'm automating a response that will resolve a block scenario. Now, that's probably not wise to do in production. You probably want to look at those block scenarios prior to killing them, but in QA, maybe that makes more sense. The idea, though, is you can run a PowerShell command for a specific problem. You can kick off a job for a specific problem. You can kill blocking for a specific problem. It's entirely up to you. And again, you can have as many many alert rules as makes sense in your environment. One of the things that I think is also really important is that we do have the ability to run an analysis. Now, even trialing the product, if you just downloaded SQL Diagnostic Manager and you're just trialing it, our analysis feature works fully even during the trial, and so it's well worth your time to try it during the trial if that's the case. If you're just using or if you're just getting new or getting acquainted to Diagnostic Manager, you can always run an analysis as well. A lot of times it's the last option, so a lot of people sort of miss it. But here, this alert rule that I've got set up is actually set up to when a certain problem at a certain time on a certain server, we're going to look for recommendations in all these different categories. So disaster recovery, activity, resources, configuration, workload. One of the things I like about this is index optimization and query optimization. I think those are both really great recommendations. But you can run that ad hoc, or you can run it in a scheduled fashion. So let's look at what the results would be when you run an analysis. Consider that when we talk about running an analysis, what we're trying to do is get recommendations for things you can do to make that SQL instance run more effectively. Right. So again, we're going to focus in on one specific server. We're going to look at this Columbia server. If I double click on it, now I'm in that server, and all these different tabs or areas are for that server specifically. Note that I can also change. So let's imagine I was looking at this I'm looking at this overview dashboard, and I want to go from this dashboard to another server. I can just hit that drop down and flip over to that server and flip back as needed. But we're talking about the analysis feature. So let's say we're looking at the overview. I can go all the way over to analysis. Let's imagine that a schedule analysis occurred last night, or an ad hoc or an alert rule fired last night. What information am I going to see? Well, you're going to see these analysis response areas here, and you can see that I ran 4 of them 3 days ago. If I double click on this point in time, or whatever point in time I want to look at, you're going to see all the different recommendations that are made. Now, these recommendations are going to be prioritized. So the recommendations at the top of the screen are going to have more bang for the buck than the recommendations at the bottom of the screen. The recommendations at the bottom of the screen are, less important. But the thing that's nice to note about this is we're going to give expert recommendations and beginner recommendations. It's entirely up to you. It doesn't have to be. When the recommendations are made, you can go line by line and decide if you want to take them. Now, if you click on a recommendation, the description of the recommendation will be at the bottom of the screen. We're also going to put in what we call learning links. So if you click on, this recommendation is talking about CheckDB. If you want to know, and this is one of the recommendations I would say is more of a beginner's recommendation. But if you want to know more about the recommendation, you click on Learn About. And it'll take you to a website that talks about all the scenarios with regard to that recommendation. Now, the alert section will, this analysis section will give you recommendations for the SQL instance, but it can also give you recommendations on the code that's executing. So if you're having a problem period of time, let's imagine, you're worried about the ETL process in the middle of the night, you might want to look at a SQL instance and go to its properties. And let's say this ETL process is happening at 2 in the morning. You can always go into analysis configuration and schedule the analysis and give it that point in time, 2 o'clock in the morning, and run it for a period of time. In this case, we're just talking about 10 minutes, but you might want to run it for 30 minutes, whatever makes sense for your scenario. But any code that's executing at that time, any T-SQL that's executing at that time, if there's problems with it, we will try to give you recommendations on that specifically. Now, when we talk about finding, this is like I said, the analysis feature is available, even during even during the trial. But right now, if you're trying to find your high impact queries, or if you're trying to figure out what's going on a SQL instance specifically, one of the areas you might want to focus on is the queries tab. So here's the overview, and then the analysis is the far right. The queries tab has a few tools available for you. So the first tool is Query Monitor. Now, Query Monitor will populate signature mode, statement mode, and query history. These three tabs, right? But it has to be turned on. You can have it running all the time if you'd like. Some people will have it running only when certain problems occur, and other people will have it turned on. So, for example, under this alert actions and responses, one of the action providers that we had was enable query monitor. So you might want to enable query monitor for 30 minutes or an hour and then turn it off. And there are other people that, hey, there's no problems with the SQL instance right now. We're going to turn off query monitor. We'll use it as needed. But all those are options for you. Now, if you want to turn on query monitor, the area you go to is configure query monitor. Here, there's an enable area. This is what you check. Once it's turned on, you can decide how you want to capture query information. We do have trace available for your older SQL instances. One thing to mention is Diagnostic Manager works for our SQL 2000 and on. So even older installations of SQL can be monitored. But again, if it's an older version, you're going to have to use trace. Most people will use extended events. You have the option to pick up estimated query plan or actual query plan. If I was picking up actual query plan, just as a side note, I would go in and go into advanced and filter down to what I was trying to look at. Right? That's just as a side note. Let me go back. And then, of course, you have Query Store, and that's probably the best way to pick up query information. If you're using Query Store, obviously you're going to have great information already available, captured by Query Store, no extra load associated with it. One of the things to remember about Query Monitor is that the amount of load or impact it has on your SQL server is directly associated with whatever you're trying to capture, right? So by default, we look for any query that took longer than 5 seconds. But alter this based on what's normal in your environment. If every query in your environment takes 1 second, then I might lower this down to 2,000 milliseconds. But if every query in your environment took 10 seconds, I might change the duration to 12 seconds. Because with Query Monitor, we're not looking for every query. We're looking for the high impact queries, the queries that took longer to run. Now, consider that all these thresholds that we're looking at, they are cumulative. So if you put in a duration and you put in reads and you put in writes, all must be true for you to capture that information. Now, once you've decided what you want to capture with Query Monitor, and you set it up, it will start automatically picking up the queries in the background. It does this continuously, just as a side note. And it's going to populate these three views, like I said, signature mode, statement mode, and query history. Now, signature mode, in this view, what you're going to see is there's going to be an occurrence column. So if you look at a query and I right-click on it and hit Show Query Text, you're going to see that pound signs have been put in where parameters were. And parameters were stripped so that we could aggregate the queries and figure out how often they reoccurred. So you can see, like, this query happened 80 times. This query happened 36 times. One time, 2 times. The idea behind signature mode is how often did that high impact query execute. And if you have a query that takes a minute to run, but you runs at 2 o'clock in the morning, and no one notices it, then maybe that's not a big issue. But if you have that same query and it's executing every minute on the minute, on the app, like all throughout the day, then people are going to notice, and it could be very impactful, and it's now a query that you need to look at. Now, signature mode aggregated, so like I said, all the parameters are going to be stripped. Statement mode, on the other hand, in this view, that same query, the one that I looked at a second ago, we'll look at it once this finishes loading. If I look at that same query and right-click on it and hit Show Query Text, here you're going to see that the parameters have been re-added, right? So if you had a long-running query and it executed, let's say, 10 times, and let's imagine that of those executions, 9 of them took 10 seconds. And I'm throwing out random numbers here. But let's say 9 of them took 10 seconds, and the 10th execution took a minute. Well, what's the difference? Well, here you're going to see all the different executions with their parameters, so you can figure out what the difference is with regard to those queries. Now, Note that if you're looking over the query numbers, like for example, you can see 117 over here, and then 117.8, 117.10, 117.9. These are all the different executions of that same query. So all the parameters would be listed in those SQL statements. And then, of course, query history is just, if a query is executed a bunch of different times. Here, let's just look at this one. Show query history. We're going to look at that query. It's going to jump over to the query history area, and you can see all the different executions that were captured. And you can see the outline, the ones that were, were very high on CPU in this case, or the ones that took longer, or the ones that were executed way faster down here. So query history is pretty straightforward, but it does give you sort of a timeline of that query if it's executed a bunch of different times. Now, another area that we can look at is query weights, and I think query weights is the hidden gem in SQL Diagnostic Manager. And why I say it's hidden is, if you're in a server and you look at the overview and you go over to queries, it's the fourth tab under the third area, right? So, what do you get in here? Well, a few things. Number one, query weights is not turned on by default. So if it wasn't turned on and you, let's say, went over to it right now, this would be empty, but it would start to populate as soon as you hit the tab, the query weights tab. Now you can also, by the way, hit configure and collect indefinitely, which is what I'm doing, right? So I've got collect query weights, and I've said collect indefinitely. This is by far, in my opinion, the best idea to have this turned on and collect indefinitely. The other thing to mention is that, by default, I think extended events is chosen. It's actually better to have extended events not selected. If you have it turned on this way, the way I've got it right now, we're going to use the DMVs, and it's going to put the tiniest of loads on your SQL Server. It's going to be like 1% at the max of CPU that it would consume, but for the most part, it should be less than that if you have it configured the way I have right now. So collect query weights and collect indefinitely. Now, what does that get you? Well, what it gets you, in my opinion, is it gets you a timeline of the weights, right? So you can see all the different weights, and you can see the outliers, so where something was doing a lot of work. Well, what was doing that? If I click on applications, I can see a backup was occurring. Or, yeah, I can see all the different things that were occurring by application. And I can also see by database, what database was being backed up. I can see this by client, what SQL, what box was interacting with the SQL Server, what sessions were used, what user did that work. And again, you see applications and statements, what was happening. And if you have it collecting indefinitely, let's imagine I wanted to go back to last Wednesday. Well, and see what was happening on a SQL instance. Or let's imagine someone walked in my office and said, hey, SharePoint was really rocky yesterday at 2 o'clock in the afternoon, and it was just really, taking forever to respond. What was going on? Well, one of the things you can do is use the history browser located throughout SQL Diagnostic Manager. You can open it and say, oh, was it last Wednesday? So that's the 28th. And then I can click on a period of time, and let's imagine it's 11:30-ish. Oh. Well, let's not do that. Let's do, ooh, that's really weird. Hold on. All right, so it looks like I've dumped a bunch of information or data, but here we're looking at Monday of the 2nd at 11:30, and now I can see again the wait states and the statements and applications that were causing that wait state. Another thing to mention is you can adjust the amount of time. So let's imagine I'm going to close the history browser. I'm going to go back to real time though. I'm going to close history browser. I'm going to click on this link underneath the ribbon, and now we're back in real time. And let's say I want to look at a longer period of time. Show the last 2 hours, 4 hours, 6 hours. Here, if I click on that, it's going to adjust the view. Where it should have. Yeah, it's going to adjust the view. And now I'm looking at, again, the last 8 hours. And let's imagine I wanted to zoom into a period of time. Well, I can do that. I can highlight it, let go, and now I'm in that period of time. Now, again, whenever you want to go back to real time, you click on this link. But one of the things that's nice about this tool is that if you've gone back historically to a period of time, um, you can actually go to a different area. So, for example, let's imagine, um, sorry, let's imagine that I wanted to go back to the sessions piece. If I click on sessions and details, it's going to actually show me the details from that period of time. So I can see everyone who's connected, what they were doing, and what applications were interacting with that SQL instance. And of course, I can also see the last command that any given session actually required us to run. So this is one of the nice things to have is a reaction like this, being able to go back and see exactly who was connected to that SQL instance. Now, one of the things that we want to talk about is the difference between Diagnostic Manager and Diagnostic Manager Pro, because this is a Getting Started with SQL Diagnostic Manager Pro webinar. So the important thing to note is that when we talk about Diagnostic Manager Pro, we're really talking about a marketing bundle. The marketing team has said that when you buy Diagnostic Manager, you're going to get a license of everything that you're seeing here in the dark blue. If you buy Diagnostic Manager Pro, you'll get a license for this. You'll also get a license for SQL Query Tuner, and you'll also get a license for SQL Workload Analysis. So 2 other products. So basically, for every license that you get of Diagnostic Manager Pro, you're going to get 3 different tools. And really for a very menial price difference. Honestly, it's not very expensive to change from Diagnostic Manager to Diagnostic Manager Pro. But there are reasons to get Diagnostic Manager Pro and the reasons not to. For example, when I look at Diagnostic Manager Pro and I'm talking about Query Tuner, or I'm talking about SQL workload analysis, I think that these tools really lend themselves to people where they can change their environment. Like, for example, if you can rewrite your code, or you're a developer, or you have a homegrown application, then I think that the SQL Query Tuner might make sense. Now, if every application you have is store-bought and the code is theirs, and you can't make any changes to that code, then it doesn't necessarily always make sense to get SQL Diagnostic Manager Pro, right? Sometimes it really depends if you can change the code or not, or if you're a developer or not. The question was, workload analysis only works if the Internet Explorer can see past the firewall into your database server. So workload analysis, you're going to interact with this. You're not really using this to point towards your SQL instance. You're using, I'm on this instance, but the SQL workload analysis itself is a collection service that's going to be connected to that SQL instance. This data, you're using Internet Explorer to view the data that has been captured already. The data is being held right now in a Postgres SQL database on this SQL instance, but it's being pulled back. So as you add SQL instances, so for example, if I was in administration and I tried to add a SQL server, I don't want to put in a fake name here, hold on. But if I was trying to add a SQL instance, yeah, so here, I'm going to click on this one. Now, actually, the thing that you're going to add a SQL instance, and once you add the instance, you're going to put in credentials, and those credentials and that collection service is what's going to be bouncing back and forth between the SQL instance and the collection service, right? That's, you're going to be pulling information back with the collection service. Now, Internet Explorer is going to talk to that backend server. It's not going to talk to the SQL instance that you're monitoring. It's going to talk to the Tomcat web server that's pushing out SQL workload analysis, which, so you don't necessarily need Internet Explorer to see past the firewall in that scenario. You need to see it connect to SQL workload analysis. The other thing to mention about when I talk about SQL workload analysis is this is using wait states, and we're viewing everything from 15 minutes all the way to 4 weeks. The only thing to mention is it's an easy click sort of menu, right? So you can say, I want to know about the statements, and you can click on that statement, and it's going to populate here in a second here, or it should. But you'll see more information about those statements. You'll see more information about who's connected and the logins, the top machines, and the workload associated. I'm going to come back to this. This is sort of taking a little while to populate. Apologize. I think there's something going on with my laptop today. But anyway, let's go. Let's go back. So if you're talking about SQL Diagnostic Manager, you're talking about 3 licenses. So you'll have SQL Workload Analysis. You'll also have SQL Query Tuner. Now, SQL Query Tuner is what I think is one of the highlights of SQL Diagnostic Manager Pro. So when we talk about a highlight, let's talk about what this tool can do. This is not continuously monitoring. Like if I had SQL Query Tuner, I might have a copy of it on my laptop, and I would probably use it when I wanted to troubleshoot or look at a SQL instance to get more ideas about what was going on. There's 3 things you can do with SQL Query Tuner. You can profile the instance, or view what's going on with it. You can tune individual pieces of code, and then you can generate SQL workloads or generate workloads to run against a SQL instance. So let's talk about each really quickly. Let's imagine I have a SQL instance, and that SQL instance is just running poorly, and I want to get more information about what's going on that SQL instance. Well, I could kick off SQL Query Tuner, and I would just turn on a profile session, and then the information would start to generate. Now, everything you're viewing, I ran in advance, because everything with SQL Query Tuner takes time. You can see this took 24 minutes to generate this view, where it was seeing what was going on with that SQL instance. Obviously, I'm showing you something recorded so that we don't have to wait 24 minutes. But what you can see is by wait state. So CPU, lock, IO, buffer, memory, other. And the other thing is you can filter down to the application, command, database, you name it. So if you're looking for a specific person or problem, you can filter down to it. You can also highlight areas. So let's say this is the area I want to look at because this is the peak during that time. Well, I can highlight that, and then down here the context will change. You can also scroll it around. So let's say I'm just really interested in this period of time. I can do that. But down here, when you see something that you were interested in investigating, you can click on it, and it's going to give you more information about the code and what's actually happening. But the thing that's really nice here is I can actually right-click on this and hit Tune. And Tune pulls the query out of the profile and jumps it over into a tuning job. Now, by default, the only thing you'll see is this one line. Right, that's what happens. So what you have to do is actually say perform detailed analysis. Put this checkbox on it. Perform detailed analysis gives you all the stats down here, so you can make a good judgment about what's going on. But go into the tuning job, perform detailed analysis, hit this play button, and then pretty quickly, about 2 to 3 minutes later, you're going to have results. Now, in this case, this is a pretty simple piece of code, and so by default, it took let's see, almost a second to execute by default. What we found was, because it's a simple piece of code, we only had 50 different possible rewrites that we could use to make the code work more effectively. So if you have a more complex, a really large SQL statement, there's going to be a lot more cases. It doesn't have to be 50. We've seen people generate like 600 different rewrite cases. Now, the tool is going to generate all these different rewrites, and it'll show you down here. It's also going to rerun them to get an idea of what's going on. Some of these rewrites are going to be winners, and some are definitely not going to be winners. So that's one thing to remember. Now, down here, you can see the ones, like, for example, this one, that's a big loser. It took way more, double the time. But here you can see that I can get this query down to 0.27, so a quarter of the time effectively. And if I expand that out, I've got all these different other executions that happened. And well, what's the difference? Well, I can right click on this and say compare to parent, and if I do that, bear with me, you can see the differences. So here's the parent, or the original, and here's what Query Tuner is saying would make the query run more effectively. Well, how do I know it's going to actually run as effectively as this is saying? It's saying, 0.27. Is that an anomaly, or is that something that's going to happen continuously? Well, one of the things we can do is after we compare to parent, we can copy these different statements out of the, so I can copy the original, copy the rewrite, and I can generate a SQL workload, right? So here I put the parent, the original, and then here I put the rewrite. And we gave it the same parameters for the executions. And what you would do to verify this, if I wanted to quantify the difference, is you'd start a new profile session. You would kick off the parent by hitting this play button. It'd run and figure out how what the actual workload is. And once it's done, you'd switch over to the rewrite, verify that it had the same parameters, and then do that same run option, and then you can quantify the actual difference, and you can see if there's really much of a change or if it's way better or way worse, right? So a lot of, this really lends itself, to developers, or if you've got in-house applications or, anything that you can actually change, this is, quite helpful. So that's the big difference. Diagnostic Manager is everything you see in the dark blue, and Diagnostic Manager Pro is two other tools, SQL Query Tuner and SQL Workload Analysis, that will help specifically if you're a developer. But okay, so I know we only have like 9 minutes left in the discussion. We've covered the queries piece. Let's cover some other really cool areas. Let's imagine I've got a blocking problem. Again, if I hold my cursor over any red X, I can get a highlight of what the problems are on that specific SQL instance. So here I'm looking at the Columbia server, and I've got a blocking problem. So I'm just going to follow the breadcrumbs. I'm going to double click on this thumbnail. It'll take me to the dashboard. The area that needs attention is red. If I hold my cursor over it, you'll see it's blocking. If I click on that, it'll take me to the sessions piece. And I've got a nice graph showing me the blocking that's going on over that last period of time. Well, if I click on the graph that I want to look at, it will actually take me to the blocking chain. So here I can see all the sessions that were blocked, and I can see the lead blocker. And down here, we've also got deadlocking reports and blocking reports. One of the things that's important to note is that although there's a default polling interval for Diagnostic Manager, that default is once every 6 minutes that you poll the instance to get sort of a snapshot of the server's health. Even in between those polling intervals, we continuously look for blocking and deadlocking using what we call an activity monitor. It's in the properties. But here, if I want to sort of a report on this blocking problem specifically, I can double click on it and see the lead blocker and the commands that are being used, who's doing it, what application is doing it, that kind of thing. If I'm looking at deadlock, same thing. I can double click on a deadlock that occurred, and I can see the session that was killed. I can see the session that survived, and this is exportable. So if I want to pull it out and show somebody else, or show some third-party support team, I can absolutely do that. But like I said, blocking reports are here, deadlocking reports here, blocking reports are here. So let's imagine I want to get more information about this SPID. Well, I can always right-click on it and say View Session Details. They'll take me to that SPID in question. This is going to actually show me every session that's running, so I can sort of get an idea of what's going on. First thing to note is that you can sort on any of these detailed views. So if I want to look at this by application, host, and user, I can pull that up, and now I can see the blocking is coming from me, from my VM, from Management Studio. Now let's imagine it's actually talking about a report or talking about somebody else that's causing this blocking problem. Another thing to mention about Diagnostic Manager is all the information that's in here you can pull out. So if I wanted to right-click, I could actually export this to Excel, and it'd come out in this format. So let's imagine someone's running a report. I want to see if they're done running the report, or if it's an anomaly. I can export it to Excel. I can email them that information. It'll come out in this format, whatever any way you've manipulated this information. Again, I can also kill the lead blocker as well. So that can be helpful as far as getting rid of a blocking problem. But okay, The other thing to mention about the blocking when we're looking at this is that well, no. Well, the exportable part's great, but the other thing that I think is important is, let's imagine we're not looking at a blocking problem. We just want to see what was going on any given SQL instance. Well, we can sort all these columns. So let's say I want to look at every session by CPU. Here I can see what was being run. If I want to look at every session by memory usage or physical I/O, again, I can see everything that was going on. And the idea behind this is we've got all this session information, and it's available historically. So if I wanted to go back, you know, here's Tuesday the 27th at 11:45 p.m. I've got that information available, and I can see exactly who was doing what, when, and where on this SQL instance. So we've covered some of the highlights of the tool. I know we've got about 5 minutes left. I'm just going to cover a few other things really quickly. And again, if there's any, I know we only have 5 minutes left, so if there's any specific areas or questions you have, put them in the questions piece, and I'll try to address them in the remaining period of time. Well, the other thing I will say is that if your boxes are VMs, and something to note about Diagnostic Manager is that we can monitor on-prem instances, we can monitor VMs anywhere in the cloud, and of course we can monitor VMs specifically and their underlying hosts when it comes to VMware and Hyper-V. That's not a problem. We can also go a step further. If you have databases as a service or managed instance in Azure, or you have Amazon RDS installations, we can monitor all of those cloud components as well. They can be added. One of the things that's nice about our metrics is we actually have metrics that can help you with sizing. So if you don't have enough resources in your Azure database as a service, we can alert you to that. If you have too much resources and you're not actually using them, like for example, if you've paid for some number of CPU and you're running at, like, say 1 or 2% CPU all the time, we'll alert you to that too, so you can save money. Because everyone loves the cloud, but until they see the bill. Okay, so looking at this, again, let's imagine you're in VMware. One of the things you can do is actually configure a link to your vCenter installation or your Hyper-V host. And after you've done that, you can link the boxes that are in that scenario to that Hyper-V host or that VMware box. And what it gets you is that when you're looking at things like resource utilization, well, one of the things, side note, is that you can actually adjust your dashboard so that you're viewing the underlying host or the underlying virtual machine. But if you're, let's say, looking at resources and I went to CPU, you can see down here the host as well as the VM. So let's imagine my VM's running really slow, or my SQL Server is running really, really slow. And I look over here and I find that the host is running at 1%. I'm like, okay, well, obviously that's fine, but it was actually not the host, but my VM's running at 1%, but the host itself, the pink, is running here at 99 or 100%. Well, that tells me that the performance problem is not tied to my SQL Server. The performance problem is tied to other VMs that are running on that ESX host or that Hyper-V host. So that's a way of distinguishing if the problem is from you or not. The other thing is, like I said, we can look at memory areas. So you can look at the underlying SQL Server memory usage, but you can also look at the underlying VMware host. Same thing for disk. If I'm looking at disk statistics, I can look at just regular disk statistics, whatever. Or I can look at the underlying host statistics. Thanks, I finally got that right. But at any rate, the idea here is, like I said, you can distinguish if a problem's coming from your host or your VM specifically, or your SQL Server. That being said, we've come to the end of our time. A few things to mention. This webinar happens every Thursday. We have lots of different people who run it, lots of different opinions. Everyone's welcome to attend at any given time. So I just wanted to thank everyone for coming in, and I hope that everyone has a great day, and take care, guys.